Today we're going to look at how to test to see if two things are in a proportional relationship. Okay, so one of the first ways we could test for proportionality is by using cross products. We're simply going to look at the diagonals and see if they're equal. So cross products. So in this case it would be 2 times 45, which is 90. And we look at 5 times 18, which is also 90. So yes, these two ratios are proportional to each other. Now if we look at the other one, we have 3 times 12 and 8 times 4. Well, 3 times 12, and does it equal 8 times 4? Well, that's 36 and 32. They are not equal. So these two are not proportional. It's kind of like equivalent fractions. So the first two would be like equivalent fractions. In this case, they're equivalent ratios. And the second ones, those are not equivalent fractions. They're also not equivalent ratios. You can also look from a table to see if two things are proportional. So in our first table, let's see if y and x are in a proportional relationship. Well, we can do ratios. We can also do cross products. In this case, 2 times 9 is 18, and 6 times 3 is 18. Well, those are proportional. What about 4 times 15 and 12 times 5? They both equal 60, so those are proportional. So basically you're doing cross products on a table. And you should be able to take any set of ratios on a table and this should work. Now, if we look at this bottom one, we have 2 and 5, or 2 and 8, and 5 and 3. Well, that's 16 and 15. So we automatically know that this is not a proportional relationship. So in this next one, we're going to use the same idea, except for we're going to look at the constant of proportionality. The constant of proportionality is where you do y divided by x. And since it's a constant proportionality, the answer should be constant. So let's look at these. On the first set, we have 6 divided by 2, which is 3. 9 divided by 3, which is 3. We have 12 divided by 4, which is 3. And 15 divided by 5, which is 3. So we have a constant of proportionality, which means this, y and x, are in a proportional relationship to each other. Okay, so let's look at the next one. Well, if we do 5 divided by 2, we get 2.5. Okay, let's do 8 divided by 3. 8 divided by 3, well, let's see, that is 2.6 repeating. So no, this is not an example of a proportional relationship. Now the next thing you do is look at a graph. On the left, we have a proportional relationship. On the right, we have a non-proportional relationship. So what's the difference between the two graphs? Well, for a proportional relationship, there are two requirements. One, it has to go through the origin. And in case you don't know that, that's 0, 0. 2, it has to be a straight line. If you look at the one on the right, it doesn't go through the origin. So it is non-proportional. And the one on the left, well, if we look at it real carefully, it goes through the origin and it's a straight line. So it is proportional. If you have one that does this, that's not proportional because it's not a straight line. It has to be a straight line. It has to go through the origin. Let's look at some equations, such as y equals 3x versus y equals 3x plus 2. If you were to put these in a table, x and y, in this case, we can just fill in the chart with a couple of different examples of numbers that would work. And if you did those, you could use like the test for a table. And you would get 1 times 6 and 2 times 3, they would be proportional. You could use the constant of proportionality, and every time it would be 3 divided by 1, 6 divided by 2, 9 divided by 3. It always equals 3. But let's look at what happens on the one on the left. So this one is yes, if I can get it to right, yes. And then this one on the right, let's see what happens. If I put in 1, I get 5. If I put in 2, I get, let's see, that'd be 6, 7, 8. If I put in 3, I get 9 plus 2 is 11. So let's try these out. Are these proportional? Well, we could simply do cross products. If we did that, we would have 10 and we would have 8. So no, it's not proportional. We could do a constant of proportionality. We would do 5 divided by 1 is 5, and 8 divided by 2 is 4. So the constant of proportionality is not constant, so it's not proportional. So this is a big no. It's not proportional. Any equation that's proportional will be in this form. It'll look kind of like y equals 3x, or it might be y equals 5x, or y equals 1/2 x. All of those are examples of proportional relationships. So there's a lot of different ways to determine if relationships are proportional. So make sure you go back and study them because it's something you need to know.